So, short lesson today. All we're going to do is talk about the formulas, and we're going to do reading problems. And then I'll give you some out of the book. I'll just put the book up under there and let you just read them from there. I'm just going to give you like maybe 3 or something, and then I'll let you work on your worksheet, okay? So it'll be a short lesson. And y'all can help each other, but like, don't be breathing all over each other. And you don't have to memorize the formulas, okay? We're still on 4.1, okay? Still on 4.1. You do not have to memorize the formulas. I will write the formulas on the board when you take the test. Now, let me ask this question before we get started so everybody can just calm down. If you don't get the reading problems, will you fail the test?
No.
No. People, is this even half of what we've learned? No word. We spent days on stuff, okay? So maybe you won't make a 95 or better, okay? I think you can still make an A if you don't do any of the reading problems, but it's gonna be a really low A, okay? So, and that's only if you're good at everything else, okay? So if you don't know how to do something, a skill, then you need to make sure you're good at the other skills. All right, so here we go. The first formula is called arc length. Okay, the first formula is called arc length, and this is what the formula looks like. S is equal to R times theta. S is equal to R times theta. Okay, so a couple of things. The very first thing is you must put the unit of measure. All right, so if we're in feet, you're going to put feet. If we're in inches, you're going to put inches. If we do degrees, you'll put a degree. If it's in radians, what? Yeah, there will be nothing. So if you write something without a unit of measure on it, I'm going to assume that you think it's radians. Okay? So let's talk about what all these variables stand for. What does S stand for?
Yeah.
Give me one.
It's in your notes. But we only mentioned it like 1 or 2 times. And it's new to you, so I'm okay that you're looking it up.
Intercepted arc.
That's exactly right. So S is the intercepted, which means the arc that's cut off, okay? The intercepted arc. The arc that is cut off by this angle right here, okay? What is R?
Radians.
Yeah. Okay, and this theta right here. Obviously, theta is my angle, but it must be in radians. So if it's not in radians, then you're going to have to use the skill that we learned yesterday, where we converted from degrees to radians, and then you can put it in the formula. Okay. Anytime you see a theta, the angle has to be in radians. Okay. If it's not in radians, then you're going to have to convert it. All right. So here we go. First problem, example 5. So here's what it says. Example 5 says you have a circle of a radius of 4 inches. So got me a little circle right here. I know that the radius is 4 inches. I'm always going to draw a picture, okay? Because a picture is worth 1,000 words. Sometimes I'll go out here and I'll go, okay, radius equals 4 inches. Notice how I'm putting the unit right there? Because if this is multiplied by something, like when I multiply this radius by this angle, then what is the arc length going to be in? Inches. He's going to determine what your arc length is in. Okay? So find the arc length intercepted by an angle angle of 240 degrees. Okay, tell me what this represents.
Your angle,
Yeah, this is my
Theta.
angle theta, except what am I gonna have to do?
put it in radians.
Very good. I'm gonna have to put it in radians in order to use it. Okay, so they're asking for my arc length, they're asking for S, so I'm using this formula. S is equal to R times theta. Alright, S is equal to, what's R?
Radius.
What is it?
4.
4. Okay, now I have to find theta. Y'all, you have the angle, but remember what we said, it's very important. You're gonna have to get used to this. If they're talking about theta, then it has to be in radians, okay? So you're gonna take your 240 degrees. How do I convert 240 degrees to radians? Okay, so theta is equal to 240 times pi over 180, alright? So theta is equal to, so I take my little, I'll tell you what, let's just do it like we did it the other day, okay? So I don't have to pull my calculator out right now. But I will tell you this, I will have my answer both ways, okay? On my worksheet and my test, I will have my answer both ways. Some kids will leave the pi in the answer, and some kids will evaluate it all on a calculator. I don't really care, okay? So if I did it, I'm gonna knock these zeros off. I'm gonna say the biggest number that divides into 24 and 18 evenly is what, 6? 6 goes into there 4 times. See, this is really over 1. If that bothers you, you can do that. 6 goes into there 3 times. So 4 pi over 3 is my radian answer. All right, everybody okay so far? Okay, so now I'm gonna take it, I'm gonna plug it in right here. Okay, this is a fraction. How do you multiply fractions? Top times top, bottom times bottom. What's 4 times 4 pi?
16 times.
Bottom times bottom.
3.
So there's my answer. 16 pi over 3, what? Inches. If you wanted to, you could pop that in your calculator. So you could go right here and you could say 16 pi. Make sure you use the pi button on your calculator and not 3.14. And you're going to divide that by 3. And so that would be approximately 16.76 inches. I'm gonna round off to 2 decimal places unless they tell me otherwise, okay? If they tell me otherwise, then you have to do it to what they ask or you'll lose a few points. All right, anybody got a question? Everybody okay? Mm-hmm.
Are you gonna take off if we do like IN for inches instead of the 2 little?
No. Mm-mm. Okay?
And then do you want us to change the 16 pi over 3 into 16.74?
It doesn't matter. Look, both, here's the deal. This answer and this answer are the same thing. Do you agree?
Yeah.
They're both on my answer sheet. So what I'm trying to do is I'm just catching whatever you like. It doesn't matter to me. This is exact and this is approximate. All right? So if you were taking some kind of standardized test, they might see if you know what that means when they put that in the direction. If they ask for the exact answer, this would be the answer they would be looking for. Okay? If they said approximate the answer to 2 decimal points, then this would be the answer they would be looking for. Okay? I don't care which one. Just pick one and do it that way. All right, everybody okay? There's another problem that's kind of like this that I want to do. I think I'm going to go ahead and do it now. I was going to wait till the end, but I think I'll go ahead. Sometimes if you work more in a row, then it helps a little bit. Okay, so this is, did y'all think this problem was bad?
No.
Yeah, okay, so I just got finished telling you that this stuff is kind of difficult, all right? So this next problem is much more a real world problem, and that's where the thinking process is going to have to start, okay? So let me read you this problem, and then we're gonna talk about it, all right? So, is like this. Assuming that the earth is a sphere, what does a sphere look like?
A big 3D circle.
A big what? A ball, okay? So it looks like a big ball. I wish I had a ball, because this is on video, I'm trying to be a little more. Y'all can turn around and look at me, but they can't, so.
Is there anything on the
Use
screen?
the key card.
Just put like,
Just hop in front of the screen.
Oh, no. Oh, no.
The whole guy.
Okay, so this is the earth, do you agree? Everyone says so.
figuratively.
All right, so this is the earth, all right? Do what? No, okay. Assuming the earth is a sphere of radius 6,378 kilometers. Okay, so I am gonna draw a picture on my paper, because they just told me something and I might need to know that. They told me that the radius of the earth was 6,378, and I am putting kilometers on there, and the reason I'm doing that is because I know that, that's gonna be, he's determining my unit of measure, okay, and I've already told you you had to have that. All right, so here it is right here. What is the difference in latitudes? What's a latitude?
Like a ladder. Long way.
A latitude goes around the earth, okay? Longitudes go up and down, all right? So, but what is it? It's a what? Is it a length?
It's a line.
Yeah,
It's a degree. but-
It is a degree, okay? It is a degree. Latitudes and longitudes are angles, okay? And they are given in degrees, so I need to be thinking about that. What is the difference in latitudes of Syracuse, New York, and Annapolis, Maryland? Where Syracuse is 450 kilometers due north of Annapolis. Okay, so what part of this sphere do we live, drive, work, walk, play on?
top.
The land.
Yeah, where is it? Is it inside?
It's the
It's on the
outside.
surface.
Yeah, it's on this surface right here, okay? So if the earth were like this, okay, they just told me that Syracuse, New York, right here, is 450 kilometers north of Annapolis, Maryland. What does that 450 represent?
Your arc one?
Oh, there you go. It is on the outside of this ball, which is a circle, okay? So like on a picture, you might say this is New York and this is Maryland, and they are their arc length between them is 450 kilometers. They're asking for an angle, okay? Now let's do our stuff. This is a what? What is this?
The radius.
A radius. So I know that this is my radius. What is this?
Arc length.
Arc
Theta.
length. What's the variable for arc length?
Radians.
S.
Oh.
So this is S. Is there a formula with an S and an R and some kind of an angle?
Yes.
People, it's the only formula you know, okay? So it's this formula right here. If I have a formula with 3 things in it and I know 2 of them, can I find the third one?
Yeah.
Very good, so let's do that, okay? The formula says S is equal to R times theta. What is S? What's R? How do I solve for theta? Okay. So this goes away, and theta is equal to. So I'm gonna take my little calculator. I'm going to say 450 divided by 6378. And there is my theta, okay? There is my theta. 0.070555032. You know it keeps going forever and ever, all right? So I'm gonna write it as 0.076. Now listen, 0706, sorry, right?
Yeah.
Okay, now listen to me. The higher up you get in math, the more your teachers expect you to do this kind of stuff. I wrote this on my paper, but anytime I wanna use this, I'm using this guy right here. Do you understand? I'm not gonna round it off until the very end, all right? Not gonna round it off until the very end. So, what is this? 0.0706 what?
Oh, that's, it needs to be ready.
Yeah, this is radians, okay? What did you tell me that longitudes and latitudes were given in? Degrees. So I have to change this to degrees. How do I change this to degrees?
180 multiplied by 180 over 5.
Multiply it by 180 over pi. Now look, he doesn't have a pi to cancel out, okay? So we're gonna just pop it in our calculator. Do you agree? So I'm gonna say this guy right here. I'm gonna say times. And if you want a fraction, you can do a fraction. I don't need one. So 180 divided by pi. And so there is my angle. My angle is equal to 4.04 what? Degrees. Okay, 4.04 degrees. Now, before we do this next part, I want to explain something to you, okay? And we'll talk about this some more, so I'm not going to go into great depth on it. But I am going to change this number a little bit, so before I change that number, I want to talk to you for a sec. Okay, so, do you know how you could be more specific with a length if you said that the table was 2 feet and 6 inches long? Do you get that? I could use the inches, which is a part of a foot, and I could make it smaller. I mean, I could make it more precise. Do you get that? Okay, so degrees is like the biggest kind of an angle, biggest part of an angle, all right? Now, you could have minutes. Now, I know that you look at that and you go, what? Minutes? I thought minutes was time, all right? But it also stands for a portion of a degree. Like an inch is 1/12 of a foot. Do you agree with that? A minute is a part of a degree. So, degrees, minutes, how do you spell it?
Wow.
M-I-N-U.
M-I-N-U-T-E-S.
Minute.
Yeah, see?
Wow.
Yeah, I'm sorry. I don't know what happened, but then when I wrote the I my brain went, what? And then I couldn't find myself.
Well, I
Sorry.
make mistakes, that's why white out there.
That's right. M-I-N-U-T, yeah. That's so sad, I couldn't even spell minutes. Okay, now, guess how many minutes it takes to make 1 degree?
60.
Yes. Isn't that nice? So 1 degree is equal to 60 minutes. Okay? Guess what minutes can be divided up into? Seconds. Okay? Guess how many 1 minute equals what?
60 seconds.
60 seconds.
Oh my goodness.
Okay? Now, I'm gonna show you what their what the symbol is, or whatever. Alright? This is degrees. You already knew that one. Okay? This is minutes. And this is seconds. Okay? Degrees, minutes, and seconds. Alright, so used to a long time ago, before we had fancy calculators, when I was in school, okay, we had to convert decimal degrees, that's what this is called, to degrees, minutes, and seconds, and we had to do it by hand. Alright? Y'all are fancier than us, because y'all have a handy-dandy calculator. Alright? So, do you see this blue word angle? He lets you do all kinds of stuff with your angles, okay? So I'm going to, where did that angle, oh, I need to go back. Can I delete this?
No, don't hit clear. Hit clear.
Thank you. Okay, so, back where I'm supposed to be. So I'm gonna go second and angle, cause the blue button gives you the blue writing. Everybody agree with that?
Oh, yeah.
Do you see degrees, minutes, and seconds?
I know.
Okay, so here's degrees, there's the symbol, here's the minutes. Now, do you see the symbol for seconds?
No.
Okay, I don't know, they probably brought an English person in to work on it, cause here it is, way down here in the green. I don't know why it's way down there, but anyway, so there it is. But look at that handy button. Hey, you wanna go to degrees, minutes, and seconds? Yes, I do, so I'm gonna choose number 4. And he's gonna say, lady, do you wanna take your answer and change it into degrees, minutes, and seconds? Yes, sir, and there it is. 4 degrees, 2 minutes, and 33, we're gonna round it off to the nearest second, 33 seconds. Those are the same thing. Okay? Now, one of the reasons that I'm not gonna push it right here so far is because back in the olden days, latitudes and longitudes were always given like this, okay? But now that we have GPS systems and all that kind of stuff, they're much more apt to give them in a decimal degree than in a degree, minutes, and seconds. So have y'all ever seen anyone like this?
Something like that.
Okay, so they used to all be given like this. Now they don't. They're gonna give them as decimal degrees. But I do like that you know that, okay? All right, anybody got a question? Okay, so that really wasn't too bad. What was the hardest part? That you had to understand that when I talked about the distance from New York, Syracuse, New York, to Annapolis, Maryland, that you had to understand that that was on the outside of the earth and that was actually an arc length. Because they in no way, form, or fashion let you know that that was an arc length. You just had to understand that. Okay? All right, so here we go. You ready for the next one? Okay, so I'm gonna give you 2 more formulas. The first formula is called linear speed. Now, what did I say about these formulas?
They're easy.
What did I say about these formulas?
We don't have to memorize.
Yeah, you don't have to memorize them, okay? So linear speed is equal to arc length over time. Okay, so let's write it as, with variables. What is arc length?
S.
S. And time is over T. All right, there's another speed, and it's called angular speed. Linear speed is how, well, I'll explain it in this next problem. I think it'll be easier. Angular speed. Okay, angular speed is the central angle over time. Now, what are we gonna call that central angle?
Theta.
Yeah, you're gonna call it theta over T. Now, what do I know about this theta?
Is it,
Yeah, he must be in radians, okay? He must be in radians. And what you just learned is that if you solve for theta, obviously when you get it back, it is going to be in radians. It's not the pretty radians that you're kind of accustomed to seeing where it says something pi over something else. It is that decimal radians, okay? All right, so here's the next problem. I got 2 more problems to do, and then I'm gonna let you work on a few. Okay, so this one says we got a clock. Okay, so 12, 3, 6, and 9. And the second hand, how do I know which one is the second hand?
it's the
It's
skinny.
the longer.
Yeah, he's the longest one. He goes all the way out to the end, all right? So the second hand goes all the way out here, and he's gonna be 10.2 centimeters long. Okay, now what is that really telling you? The radius, okay? That's telling you the radius, all right? And here's what they're asking you to do. Find the linear speed on the tip of the second hand. All right, I'll call that A part. Oh, well, yeah, that's all they asked us to find. Okay, so what did they say on the tip of the second hand? Does that mean that this part in here, this part right here by the center, goes a different speed than that?
It's further out.
Okay, think about this. Think about, let's think about either a band or a dance line or something, okay? A band or a dance line. If these are a bunch of people in a line, okay? And they're all moving like this. Do the people in here have to move as much as the people out here? No. Who's gonna be out here? It's not me, okay? It's gonna be the long-legged people, right? They're gonna be taking big, giant steps. These people are just gonna be standing in place, all right? So is the speed out here on the tip different than the speed right here? Yes, it is. They have to move a whole lot faster, people, all right? So that's why they asked it like that. Okay, so linear speed, how fast that tip is moving around that circle. Angular speed is how fast the angle changes with respect to time, okay? So we're talking about linear speed. What's the formula for linear speed?
Arc length over time.
Okay, so arc length over time, S over T. Do I know what the arc length is?
No.
No, you don't know what the arc length is. So needs to be the very first thing I'm going to find, all right? So I'm gonna go over here and I'm gonna say, well, I don't know what the arc length is, so I'm gonna have to find it. What's the formula for arc length? R times theta. Okay, so what is R?
10.2.
10.2. Okay, 10.2, and it is centimeters, okay? It is centimeters. Okay, so, what's theta? This is the second hand. Where does it go? All the way around. What is that?
360.
Oh. Pi, 2 pi.
2 pi. Okay? Yes, you're right. It is 360, but you have to represent it in radians, so that is 2 pi. So we're going to multiply these two things. I'm just going to leave the pi on my, I'm not going to do that. I'm not going to round it off to the end. Now listen to me. When you start rounding off inside a problem and inside a problem and inside a problem, every time you round off, you skew your answer just a little bit. So if you round off a few times inside the problem, then when you get to the end, you might have the wrong answer. It might be too far off, okay? So I'm just going to multiply this by 2 and get 20.4. I'm going to put the pi on there, and it is centimeters, okay? This is the length of the arc all the way around that circle. It's just its circumference, okay? All right, so there it is. So I know that this is equal to 20.4 pi over. What's the time? How long does it take the second hand? It's not, I shouldn't have written it like that. It's really the what? The second, like SEC, sorry. That's probably confusing to some people, so I'm gonna rewrite that like that. Okay, that's me and my jotting down stuff fast.
Isn't it also the second hand technically? Because the first hand tells you the hour and then the second hand tells you the.
Second hand
minute.
tells you the minutes.
Yeah, so like second as in first, second, third.
This is the second, so it'd be the third.
So, yeah. Yeah, I see what you're saying, but, yeah,
This isn't
the, yeah.
Second hand. Our hand,
There's-
minute hand, second
Oh, I thought this was the minute hand.
No, wrong!
Oh.
That's the whole confusion with like.
That's
like
because the
this
minute hand doesn't go all the way out to the end, the second hand doesn't. That's what we said before. Okay, so are you with me?
Yes.
Okay, so what is my time? What is the time that it
An
takes?
hour.
What?
60 seconds.
Oh,
Hold on.
Wait a minute.
60 seconds, yeah.
Stop.
60 seconds.
Maybe, okay, let's do that.
Yeah.
Okay.
Can you please repeat yourself?
Why did I really just think it was only 2 meters long?
All right, so I'm gonna divide this out in my calculator, okay? So I'm just gonna take 20.4 pi. I'm gonna divide it by 60. And there is my answer, 1.07. 1.07 what? Remember I said you had to have your rate on there.
So, wait.
Centimeters.
Very good. Centimeters per, that says centimeters. Centimeters per second, okay? Centimeters per second.
That's
All right,
the answer?
anybody got a question?
Nope.
Everybody okay? Okay, so let's do one more problem. I'm gonna go to the next page only because this next problem has 2 parts to it. You probably could fit it all on there if you had lines to follow. All right, so this is example 7. All right, let me see if I can.
It's a steam roller.
Paper towels.
Paper towel.
No, it's definitely a steam roller.
No, it's a paper roller.
Okay, so it's a lawn roller.
It's wrong.
It looks like
Oh,
a toilet
what?
paper roll.
Oh, what?
Definitely
A
a steam
lawn roller. A lawn roller is a big metal drum, and they usually fill it with water. Like if they built a house and then people have been driving and walking all through the yard, or they disc the yard up and they're gonna sod it. Do you wanna disc the yard up and then put sod on top of that?
No.
I've
People,
never
your
seen
children will run out there and break their leg, okay? It'd be like running through a
Yeah.
potato patch or something, okay? So they take this big drum and they put some water in it to make it really heavy, all right? And then they drag it all over the yard and it just smooths stuff out, okay? That's really what it's for, all right? So you have a lawn roller. The radius of the lawn roller is 10 inches, okay? It makes, you could call this like its speed or something. 1.2 revolutions per second. That means every second it goes around 1.2 times. Okay? Every second it goes around 1.2 revolutions per second.
That would mean every 5 seconds you're getting 6 revolutions.
All right, everybody okay? Okay, so the first thing they want to know is they want to know what is the angular speed in radians per second. If they don't tell you the angular speed, then you can do it whatever you want to, okay? If they don't tell you the angular speed, you can do it in whatever you want to. All right, so the angular speed in radians per second. What is the formula for angular speed? Theta over time. Okay? Do we know what theta is?
No.
No? Okay, so we're gonna have to find it, right? What's a formula that you know that involves theta, but it can't be this one, obviously?
R, or S equals R.
Very good. S is equal to R times theta. Oh, sorry. You don't really need this one. I was like, we don't need arc length. I was doing the next problem. We don't need arc length yet. We're gonna do the next problem. We're gonna do linear speed. Okay? Here's something, I'm gonna write this in pink because this is really important. Anytime that you have revolutions per minute, and I wanna change it into theta, okay? What is 1 revolution?
360, or 2 pi.
2 pi. Okay, yes, it's 360 degrees, but we're in radians, so it's 2 pi. So 1 revolution is 2 pi. So what do I need to do with my revolutions?
Divided by
No, don't divide.
Times it?
Yeah, multiply, multiply. So all you have to do is take your R, now look, I'm saying revolutions per minute, but it also could be revolutions per second. It's just your revolutions, okay? And you're gonna multiply it by 2 pi, because every revolution is 2 pi. Okay, so how are we gonna find this theta right there? Well, yeah, I'm gonna say 1.2, and I'm gonna multiply it by 2 pi. Okay, I'm gonna say 1.2, and I'm gonna multiply it by 2 pi. So, I'm gonna do just what I did a while ago. 2 times 1.2 is 2.4 pi. That's my theta, so I'm gonna put him up here. Okay, what's my time?
Second.
1 second. See, per second, right there. So my answer can be 2.4 pi radians per second, or you could multiply that out if you wanted to. You could say 2.4 times pi and get 7.54 radians per second. Okay, so the next thing they want to know is my linear speed. What's the formula for linear speed?
Arc length over time.
Yeah, arc length over time, okay? Arc length over time. So, do we know the arc length?
No.
No, but we can bind it, right? We have a formula. So S is equal to R times theta. What is the radius? 10. I told you that in the problem. Okay, the radius is 10. And what is theta? 2.4 pi. So this is 24 pi what? What's my unit? It's an arc length, y'all. Inches. So 2.4 inches. So this is equal to 2.4. No,
It'd be
sorry, not
24.
2.4.
24 pi.
24 pi inches. Over, what's my time?
1 second.
Still 1 second. Alright, so if you can leave it like that, that's 24 pi inches per second. Okay, or you could multiply it out and it would be 75.40 inches per second. Either way you wanna write it. Okay? Alright, so these are the problems that I think I want you to do. Alright? I'm gonna put the book up here and I want you to work on these problems. 93, let's see what all's on one page. Okay, we'll do 93, all right? And then, I think we'll do 95A. Those are the only 2 problems that I want you to work, okay? So, I do wanna talk about this one problem. Okay, does this look familiar?
No.
This picture right here?
It looks like the lawn
The
roller.
roller.
I don't know though.
Hello?
Oh.
Hello?
Probably not like the
Don't act like that.
Okay? Your artistic teacher drew that picture, okay? So let me explain to you what this picture is, all right? Let me explain to you what this picture is. Okay, so here's what's happening. I'm trying to pick up this I-beam. Do y'all know what an I-beam is?
Yeah.
It's like a huge metal, beam, all right? It's called an I-beam because from the sides, it looks like this. Like an eye, so they call it an I-beam, all right? It's very, very heavy, so I can't pick it up by myself. So I use this thing right here, which is called a hoist, okay? Now, look, what I've done is I have a chain right here from my hoist, and I attach it to the I-beam. I'm going to turn this drum. What did I tell you about the drum?
10 inches wide.
Yeah, it's 10 inches in, for its diameter,
The radius.
okay? I'm gonna see if I can find a piece of string. I knew it had some string. Okay, so, can y'all see that?
Nope. Go a little bit further. There you go.
Yeah.
There you
Are y'all lying?
go. No, it's on
Okay.
there.
All right, so this is the drum, the hoist, okay? And so I put a chain over the hoist, and I'm going to attach this to the I-beam, okay? Now, what you do is the hoist is mechanical, okay? So it's going to crank the motor up, and then it's gonna turn, and as it turns, what does it do to this rope? Okay, it wraps it around the drum, and it picks the I-beam up, okay? So however much I want to pick the beam up is going to be how much it wraps around the drum. Do you agree with that? What would that be called? That's your arc length. Because it's wrapping around this circle, okay? This drum right here. It is on the outside of the drum. It's the same concept as that kilometers around the earth. It's on that outside part, so it's making that arc length. All right, so that might be something on your worksheet that you might want to go, oh, this is my arc length, because other than that, you're just going to be going, what does me picking up the I-beam, whatever, 2.5 inches or whatever it is you have to pick it up, have to do with anything, or okay, so that's going to be your arc length. All right, so right now, I want you to work problem, what did I say? Okay, so I'm gonna, they're on, of course, they're on different pages. Okay, so here's 93 right here. So I'll give you just a minute to do it. If you don't have a calculator and you can just set it up, that's okay. All right, because you can do that other at home. y'all get it? When it says it moves 2.5 centimeters on the scale, do you know what that's called? That's your arc length. That's from here. Look, here's my picture. Do you see my picture? Okay, so there's my radius. All right, there's my radius, and it moved 2.5 centimeters, so that would be my arc length. So I'm looking for the angle, so I put arc length is equal to radius times theta. I divide it by 6. I will tell you this, sometimes when you're not sure what formula to use, I label everything that I have. Like I would say, okay, so this is R, this is S, and I'm looking for an angle. All right, so do I have a formula with an R, an S, and an angle? Yeah, here it is right there. So I plug everything in and I solve for it. So it's 0.417 radians. Okay, they didn't ask for it in degrees. If they had, I would have converted it. All right, everybody okay? Okay, so here's 95, and we're just gonna do A part.
Where is it? Where's 95?
Oh, sorry. My good one, stay over here. Mm-hmm.
Does that say 1.5? Right?
Mm-hmm. This says 1.5. One and a half what? Revolutions.
Oh, I can see that.
Okay? So, the number of revolutions made by a figure skater for each type of axle jump is given. Determine the measure of the angle generated. What are you looking for? An angle, so you're looking for your theta, people, okay? Generated as the skater performs each jump. Give the answer in both degrees and radians. Okay, so are you with me? All right, so 1.5. What am I gonna do with that 1.5? Y'all, this is a really easy one. Don't make it hard.
That's just,
I don't even need those formulas, do I?
it's just 3/2
Yeah, that's all it is. Okay, you're just gonna go 1.5 times what? 2 pi. That'll give it to you in what? Radians. Okay? If you did it in degrees, you might understand what you were doing better. All right? A single axle is 1 1/2 revolutions. So what's the angle that the skater turns? Well, it's 1.5 times 360. Do you agree with that? 360 is all the way around, and then it went another halfway around. So what is 1.5 times 360? 540? So, for a single axle, the skater rotates 540 degrees. Does that make sense to you? Okay, he goes 360, and then he goes all the way back around, facing the other direction. He does a 180. Okay, in radians, you're gonna multiply 1.5 times what? 2 pi, and that's all they asked for. Okay, that's all they asked for. They didn't ask for the angular speed or anything like that. They just said determine the measure of the angle. That's all they asked for. Okay, so now you can get your worksheet out and you can work on it. If you need some help, I'll be glad to help.